Hello community, welcome to our Q&A about how to outsmart Microsoft's paid version of ChatGPT. So here we go. I got a lot of questions for you, and about half of them is, hey, I just bought embeddings from, I don't know, OpenAI, Cohere. How can I now build my own ChatGPT? Okay, let's look at this. I hope at first you ask Siri how to build a ChatGPT, and then you come to me and say, hey, code for AI. So what I do now with my new embeddings. Okay, let's start. You have knowledge written down in books, a lot of books. And some of those books you put in a treasure chest and you say, okay, these are my training data for the system. And then if you're a company, you lock this training chest. And I don't know, for example, if there's gold inside or some diamonds inside, it's a locked system. And then to be really transparent, you say, okay, I put this locked system, this treasure chest in a black box. And this black box will do the work for me. And every customer that approaches me will only have a black box to interact with. Great. So where are those embeddings? You have an input and an output from this black box. The input, and I've chosen here an example by OpenAI, who very clearly has in its documentation, please read the copyright reference, has how it is done. You say, okay, here, yeah, application, this is my Open API key, this is where you have the connects to my credit card, and then you have here your input. Your text string goes here. So here's your question, what you want to know, the information that you ask for, great. And you send this into the model, and then you get an output of the model. And if you bought embeddings, if you really just bought embeddings, this is the result you get back. You get back a vector, a tensor, high-dimensional tensor, a vector object representation of a vector space. And then comes the beautiful part. And at this moment, some viewer turned to me and say, hey, what now? Okay, so welcome. Welcome to my course. If you want to create an AI model you can sell to everybody on this planet, like Microsoft did. So we have, of course, if you want to sell it to everybody, we have to include all their knowledge there is on the internet. We copy the internet. Done. Of course, since every day millions and billions of new ideas and documents are generated around the globe, you have to have a cutoff date for your model. And here I can take here the documentation by beta, openai.com docs, guides, embeddings. What are embeddings? You see here you have a clear for version 1, a cutoff day, say August 2020. Stop. No data behind August 2020. Or the newer version, version 2, you see here September 2021. And it is not a coincidence that it's about a year between those models, because training those models with all of the input data, all of the training data, costs millions, if not tens of millions, if you run it on, let's say, Microsoft Azure. So you see here, this is a cutoff date, and you just put all of the knowledge you could legally allowed, respecting the copyright, copy from the internet. Beautiful. And then you have a model. And this model produces a vector embedding. And here this is what you bought of all training data. So just to be absolutely clear, the training data is all the knowledge the company put here in this data chest, this treasure chest, and locked it up for us. And the model is here, this beautiful black box that, for example, OpenAI trained on Microsoft Azure cloud infrastructure, and they have now a model. And they say, okay, if you pay us, you can use it to generate your embeddings. So a model, the black box, produces a vector embedding. What the hell is a vector embedding? I just showed you. Of all the training data. Beautiful. So now you say, okay, so I have now my vector embeddings. And I have all the data have vector embeddings, what I do now with my input vector embeddings, and how I build a system out of this. Beautiful, beautiful. I really learn a lot based according to the question of my users, but it is important that everybody understands it. So if you have here your chest and here your digital data. Now what is the main purpose of the model? The model needs to structure, to bring order in this chaos of information overflow. So the model structured input data. What is an embedding? Now have a look here at this car park. Isn't it beautiful? Now imagine you are looking for your car where you parked your car in this car park. You remember there are these beautiful huge signs. For example, A4, and you remember you parked directly under the sign A4. So this indicator, this vector embedding of the position of your car gives you the location of your car. Yes, it is this easy. This is a vector embedding. This is a positional indicator giving you a direction where you want to go, where your car is, where your data is. Beautiful. Now what does the model do? The model takes all the data from the treasure chest, and now it has to bring order in this digital data. So it says, okay, all books, all articles, all Facebook comments about politics, I put here, first line. Here are my politics. Everything about finance, I put here in the third row. Everything about science can go here. Art, literature, painting, whatever, might go here. So what you see what's happening. It is more or less a segmentation of the available space. You say, okay, to bring in order, like in a library. You say you have local places, local spheres, local vector spaces where you assign the data to. Beautiful. So now imagine this is you. You are driving a blue car, and this blue car is at this position, and you have an input query. The car symbolizes your input query. And you say, hey, show me the information about politics. And you have no idea how this parking lot is organized. So you get an embedding. You get, like the A4 sign, you get a vector showing you the way where you have to go to, where to locate your data. And this arrow, and you say, hey, I know from school, arrow, two-dimensional Euclidean plane. Yes, I know there's an X and a Y coordinate. That indicates here the direction of this indicator. I'm so proud of you, because you see, if you take this symbol now, and we have here our input string that we put into our black box. This is our blue car. And out comes, and now you know what is an embedding. An embedding is a vector representation in a particular created vector space. And this vector space was created here by our black box. So this black box took more or less here all the digital data and ordered it in a particular way, so it knows exactly if you have a question, hey, show me data about, I don't know, about Picasso. It knows exactly where Picasso is, and it tells you, hey, the machine code of your question, the embedding of your input data is X, Y, Z. Beautiful. Now, you see here, I didn't put any symbol here in the black box, but to be a little bit provocative, LLMs, and this black box is an LLM, like ChatGPT, for example. 50% of the work people invested in them is to clean data. Because imagine in this data chest here, in this treasury chest here, we have all Facebook comments. And you can imagine that some people on Facebook are emotional. Some people have some very polarizing speech. Some people are very emotional and maybe write something they do not really mean. but there are some words you do not want to have or communicate to other people. So here you have a huge filter, a filter plane here that's going on just to absorb everything that is connected, if you want to call it hate speech, to get rid of this. And it is amazing the resources and the capacity and the man-hour and the compute time that run into the system just to, let's say, clean the data from some human polarizing speech. Without this, my goodness, life would be so much easier. So just for you to imagine, this huge filter is not indicated at all. I just wanted to show you. Now that you have embedding and you understand what are embeddings, indicated to a particular region in vector space where the system placed all the information that you ask for in your input string, now you have the path to go there. Oops. And you see there are some other system representation you choose here, floating points. And you say, okay, what are those figures? Now imagine you have a two-dimensional car park somewhere on the field. And then you go to the city and you have a 3D multi-story car park. This is more or less, you just add layers, dimensions to the model. 3 dimension, 4 dimension, 5 dimension. You can color code, I don't know, the right side is red and the blue side and the left side is blue. So you have further distinction here that you can incorporate in a particular vector representation, a tensor. So you see, easy, you go higher dimensional embeddings. And now you might say, hey, great, now I know what a model does. I know what embeddings are. And I tell you, no, you have an idea now, but only in theory. Why? At first, if you are a client from one of those companies, you do not know what's in this hidden away and closed up treasure chest. You have no idea what are the original data that the system was trained on. And the system can just do something where it has the data. If you are in a particular topic where there were no documents or no data files available, and is not represented here in the training data set for the model, you will get a very particular answer because it does not have segmented the knowledge, comparted the knowledge in a way that will give you an answer that is satisfying. You do not know the model. You do not know this black box, how this black box operates, what kind of technology this black box uses, how much man-machine, human interface bias, whatever, is generated because of the architecture and the quality of the input data. You do not know nothing about the system. And as I told you, you do not know the relevance for your input, since you neither know the input data nor the processing unit. So whatever comes out of this system, if it is relevant or not, I cannot give you a trustworthiness index, an integer between 0 and 1. And you see, this is where other systems come in play. And if you ask me, can I build my own GPT? The answer is no, because you do not have the resources of Microsoft Azure. But you can do something more clever, a smarter system. Look here, this is my two-dimensional OpenAI carport. And now you see here, here, almost at the horizon, we have a specific topic. And this is quantum field theory. This is something in physics or mathematics or whatever you have. And because the car park has a limited size, ChatGPT has to run on a supercomputer from Microsoft Cloud. This here, and if you have 10 million topics or 100 million topics, the size for some outlying topics, maybe there are just 3 cars that characterize quantum field theory, or 3 spaces here. So if I have now a very dedicated input, and I ask specific about this topic, although the machine has 100 million other topics, this topic, it has only 3 car spot spaces available. So You see where I go from something that is everything for everybody, like ChatGPT, which is amazing, but it needs a cloud supercomputer, to something that is highly specialized, like we humans. Somebody has a specialization. Somebody is gifted. Somebody is a painter. Somebody is a creator. Somebody is, you know what I mean. So this system here now, for example, these 3 core places, what I call quantum field theory in physics, it is not anymore a large language model because it is not all circumventing everything. It is a highly specialized focus system on 1 or 2 topics only. Therefore, it does not qualify as a LLM. We call this a neural search model, if you want. But you know what? If I build this system only on 1 topic, and I use the same car park here, like before, and now all cars here, let's say we have 10,000 cars here in our picture, are all specific detailed data on a highly detailed level, all about QFT. So I have now really a specialized system for all details for every aspect of this topic. Where in an LLM, I just had 3 core places here somewhere at the end of the horizon. Now, if I have a specialized system, I can use all my places here that I have available, all my cores here for this particular topic. And this is really a deep dive into this topic. If you want to build such a system, in this video, I show you how to build it. Easy. And if you want to know about the difference here, because ChatGPT, you would not guess what GPT stands for, and BERT, they are more or less, the whole is a transformer infrastructure, transformer invented by Google. And the encoder stack here on the left side is BERT, and this is what my specialized focus system would be, where I have some transfer learning, where I can continue learning every month. And this GPT, like ChatGPT by OpenAI, the further development that is based on GPT. You see, this is here the decoder part of the transformer. And if you have a decoder stack of 24 or 36 layers or whatever, how many layers you have, transformer blocks you have operational in GPT. So you see, these are more or less very similar architectures for your AI. Either you go with a system, an LLM system like ChatGPT, that you have a supercompute center run by Microsoft. Yes, you have to pay Microsoft if you want to use it. Or you have a very specialized system, also based on a transformer model, not an LLM that is everything to everybody, that is highly specialized just for me. This system I can run on my home PC. Oh, yeah, wait. So to summarize those alternative systems, if you ask me, can you build your own GPT? No. I mean, if you are multi-billionaire, yes. You just buy a cloud supercomputer, and then you can run it there. But normal people, normal companies, normal universities, no way. This costs too much. So ChatGPT runs on a supercomputer center because it has to include almost the whole knowledge that we have. It is every topic including for everybody. It is a black box system. We do not know what the companies who trained the system put in there, how they trained it, the parameter. It's a black box. It's a black box regarding the data content, and it is a black box regarding the model architecture. And as you've seen, the data I showed you before, it's hard to update because you have to run the whole system. And if you say how to fine-tune GPT, for example, because you freeze 90% of the very early layers and you just update 10% of the decoder stack architecture. Yes, I know it is a way currently if you fine-tune this, but if you compare this to the other model, this model is a highly dedicated, specialized model. It's not an LLM. but it's a neural search model that operates something very close to an LLM, but it is absolutely focused on one topic, like quantum field theory, physics here for me. It is a professional focused system. I have more than, I don't think, 20,000 publications, only scientific publication. I don't have to clean the data for hate speech because I only take pre-reviewed journals. It has a very narrow focus, but data from all over the world, all R&D department. I think for the last 10 years, I have every publication in this particular topic published. And I can run a neural search on this. I have it in my home. I have it behind several firewalls. Cybersecurity, if you are a company and you have very sensitive data, you do not want to have it in a cloud, although clouds are very safe today. But if you insist that you want to have it in-house in a dedicated entity within your company, you have here the advantage of this system. But again, this includes everything for everybody. And this is a highly dedicated, specialized, professional, focused system. So this is an alternative to ChatGPT. And chat is really, really the correct term. It just chats with you. It says blah, 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 blah. And here, this system here does not chat at all with you. The output is purely professional, hardcore data. Full stop. No, hey, how are you? Do you want your output in a special form? Do you want whatever? So, black box system. So all the viewers who ask me, hey, what about my embeddings? What I do now with my embeddings? You have to think a little bit different. You need to perform a task on an LLM. We call it a downstream task, like a search. You are searching for some information. Therefore, your input query is transformed into an embedding. And text vector embeddings measure, for example, the closeness, the similarity, the relatedness, my goodness, of strings of text. And of course, you know, we do this with the cosine similarity function in a defined vector space where we have even maybe a metric. So you search then for your specific information, you have your input string, and you get a result back from the black box. And for example, the result is the information ranked by relevance to your query string. Beautiful. If you want to have very good documentation, again here, please check beta openai.com docs guides embeddings use cases. I think they have an excellent literature where they show you what you get back and how to operate this. Now, an LLM, because it's so huge and it includes everything for everybody, it has to run on a supercomputer center. So what it does, and this is really the task that it performs, it is convert your input text to a vector embedding. This takes time. This takes compute time. It compares this vector representation, normally in the form of a tensor, against all other vector representation it has stored in the last run of the training run of the system. Those huge data of all the digital internet, or main part of the internet, has a data storage somewhere at the supercomputer center. Either it's cloud or Azure or wherever you are. So you have to pay for data storage. And then the performance, as I showed you the cosine similarity function, if you combine your input against all the other input on the internet that it has been digitalized and included into a vector representation of an LLM. My goodness, this is a main part here. You compare one tensor to, I don't know, 100 billion tensors. And then you have an output and you have to convert this output from code to human text. And all this has to be executed in a supercomputer. And damn, it takes time, it takes energy, it takes a lot of resources, CPU, GPU, TPU, everything on the network, everything. Somebody paid for this to build the whole, to build all the infrastructure. And you use this, and of course you have to pay for this. So yeah, If you have ChatGPT, then this output, for example, you can say, hey, give me the output, a search result in a particular form. Give me a Japanese haiku or, I don't know, a French poem. All those things cost compute time. I mean, heaven's sake. And then, of course, yeah, I see example. Can you give to me the results in the form of a speech that Winston Churchill would have done? Well, yes, the system can do this because let's call it the neural interconnectivity, or if you want a simple way, the template is available for this. But yes, on a supercomputer, if you execute this, you have to pay for this. And up until now, in the beta version, or in the free version, in the research version, or however you want to call this free version, Microsoft paid for this because they provided you the infrastructure for free. If it came from the marketing department of Microsoft or not is not a question. But yeah, it always did cost a huge amount of money. So have a look again, openai.com, API pricing. They have very detailed information on pricing. And they show you exactly what it costs if you have an input text. If you compare this, if you have then the storage, if you have compute time, if you have conversion, if you have further. They have very simple formulas. You can really calculate the pricing for your specific task. Okay, this was it. Short overview, short Q&A for you. I hope there was something in for you. And if you have any other question, do not hesitate to ask me. Until then, I see you in my next video.